Good evening, I am Mr. Ish. We're looking here at inverse trigonometric applications. Technically, we're really looking here at calculus applications of trigonometry, but just because I'm using the word calculus, it doesn't mean it's totally out of our league over here. This is very much high school or 12th grade level math we're looking at over here. And it is a big part of calculus. If you do ever go into calculus, these are basically trigonometric concepts, but they'll have calculus applications down the road. The type of questions we're looking at are these. If you have supposedly, hypothetically, sine theta is equal to some value and that value is equal to x, you solve for this expression in terms of theta. You take the sine on the other side and you generate an inverse sine or an arc sine x. You can write the same thing as sine minus 1 x, alright, arc sin or inverse sine x. All you've done is make an inverse trigonometric function over here of something which was not an inverse. It was a regular sine, but you took it on the other side, you solved for theta, and you generated an inverse sine. Anytime you're looking at questions of this type, you are looking here really at an x over 1. When you're looking at this, you know theta is equal to all of this. Then using that, you have to generate a triangle, a right triangle, and map it out based on what you see, based on the function you see right over here. You're seeing an inverse sine x over 1 and you're trying to see that theta is equal to that. Look at the value and the definition of sine. Sine is always equal to opposite over hypotenuse, and this can be your opposite over your hypotenuse, x and 1. And then you find your missing side using the Pythagorean a square plus b square equals c square. And then you know here this value will be this square minus that square under a square root. Now you've generated your third side just simply from this expression. Now with regards to this theta, you can find all 6 trigonometric functions. You know sine theta over here is equal to opposite over hypotenuse, which is just an x, and that's exactly what we started with. So we know we're on the right track. Cosine theta is equal to adjacent over hypotenuse, which will be square root of 1 minus x squared divided by 1, but over 1 is meaningless here. Tan theta with regards to this angle is equal to opposite over adjacent, x over square root of 1 minus x squared, and you don't have to rationalize here. You can keep your answers as you see it. Then cosecant theta, which is your reciprocal of sine, is equal to hypotenuse over opposite, which is 1 over x. Secant theta, which is the reciprocal of cosine, is equal to hypotenuse over adjacent, 1 over root 1 minus x squared. And then of course cotangent theta, which is your reciprocal of tan, is equal to adjacent over hypotenuse, root 1 minus x squared divided by x. And suddenly from this simple expression here, you've generated values of all 6 trigonometric functions using inverse trigonometric applications. And this is the gist of this video. And we will be looking at 2 questions which will involve something. It won't be this elaborate, but 2 questions. You'll start out with what you are given and you'll solve for theta and make it into an inverse trigonometric application. You'll utilize that inverse trigonometric application to start mapping out your triangle, a right triangle, in terms of your theta, find your missing side, and then go from there. We will proceed with an easy to a hard question, and we'll look at 2 questions. And we're looking here at evaluate. And let's say we're looking at cosine theta is equal to 1 over 2. We have to basically end up finding tan theta, and we'll say we have to find cosecant theta. Alright, that's what we're doing. We're not going to find all 6 from this, we'll find only 2. So when we're looking at this, cosine theta is equal to 1 over 2, then we solve for that theta. Theta is equal to arc cosine, which is the same thing as inverse cosine, 1 over 2. I'm going to use the word arc cosine here. You can use inverse cosine or cosine to the power of minus 1. It's all the same. And we'll utilize this expression right here to generate our triangle sides. You always put a triangle like this, right triangle, and aim it, this vertex, towards the right. Put your theta over there and map it out based on the definition of this thing you see here. Cosine is equal to adjacent or hypotenuse. See, adjacent or hypotenuse, and find this one. Using a square plus b square equals c square, that will be 4 minus 1 root, and you'll have a root 3. Now you have to find tan theta and you have to find cosecant theta. Tan theta is equal to opposite over adjacent, which is root 3 over 1, which is just root 3. It looks right to me. Cosecant theta, well, cosecant theta is equal to hypotenuse over opposite, and that will be 2 over root 3. and both of these answers will be right. So you're seeing the gist of these questions. Start with what you know, convert it into inverse trigonometric function. From that inverse trigonometric function, map out your triangle, then actually evaluate what you are being asked to evaluate. We probably will have to do another video just to cement the idea, but for this video, this right here will be our last question. If cotan theta is equal to 1 over x, we have to find sine theta and secant theta. Always start with what you are given and then utilize that to map out your triangle. Cotan theta is equal to 1 over x, theta is equal to, you take the cotan on the other side, you have arc cotan 1 over x. This right here is what you use to map out your triangle. Draw a triangle, right triangle, aim this vertex towards the right, make this your theta, and use the definition of cotan to place these values on the sides of your triangles. Cotan is always equal to adjacent or opposite, see? And that's exactly what you're getting. Find out your third side using the Pythagorean theorem. X squared plus b squared equals c squared, or a squared plus b squared equals c squared, and this right here will be x squared plus 1 root. Now you have to actually find this. Sine theta is equal to, based on this, opposite over hypotenuse will be x divided by square root of x squared plus 1, and that looks right to me. Secant theta will be equal to hypotenuse divided by adjacent with regards to the angle right here, x squared plus 1 within a root divided by 1, which is just square root of x squared plus 1, and both of these answers are right. And that right there is this video completed on inverse trigonometric applications, also called calculus applications of trigonometry. Thank you for watching. Stay tuned. Have a nice day.